So here's a question from the JEE Advanced Math Paper 2, 2021. And the question has a question stem, and we are asked to evaluate two different integrals. So let us read the question first. G sub I is a function from pi over 8, comma 3 pi over 8 to the reals, and I can be equal to 1 or 2. The definitions are given below, and f has the same domain and codomain. And g1 is equal to 1, and g2 is equal to the mod of 4x minus pi, and fx is equal to sine squared. And again, the domain of f of x is also equal to it is also equal to pi over 8 to 3 pi over 8. Now, s sub I, the integral, is defined from pi over 8 to 3 pi over 8 of f of x times g sub I x dx. The first question is to find the value of 16 s sub 1 over pi, and the second one is 48 s sub 2 over pi squared. So let us figure that out. The integral s sub 1, that is equal to 3 pi over 8 from pi over 8 of f of x, so f of x is just sine squared of x, multiplied by g1 of x, and g1 of x is just 1. So this is a relatively simpler integral compared to the usual types of tougher integrals. We can write the sine squared function as a simpler trigonometric function in terms of cos of the double angle, that is cos of 2x. So notice that we can write sine squared of x as 1 minus cos of 2x divided by 2 dx. This one has no real meaning. And now it's as simple as just writing the antiderivative of this function. So the antiderivative of half is 1 by 2x minus the antiderivative of cos of 2x is sine of 2x divided by 2. And notice there is another 2 right here in the denominator, so we just write that as well. And this has to be evaluated from 3 pi over 8, from pi over 8 to 3 pi over 8, And now we just put that value right in. So 1 by 2, 3 pi over 8 minus pi over 8 minus sine of 2 times 3 pi over 8 divided by 4. And then plus, since negative and negative again, plus sine of 2 pi over 8, this divided by 4. So sine of 3 pi by 4, sine this, let me just write that again, that will be a better strategy. So 3 pi over 8 minus pi over 8, that is equal to, well, this is equal to 2 pi over 8, or pi over 4. So half of that is pi over 8 again. Lots of pi over 8s now. Minus sine of 2 times 3 pi by 8 times 2. Well, this is equal to 3 pi over 4. And sine of 3 pi over 4, that is sine of 135 degrees. That is just equal to sine of 45 degrees, and that is equal to 1 over square root of 2. So negative 1 over square root of 2. This plus sine of 2 times pi over 8. So 2 times pi over 8 is equal to pi by 4. Sine of pi by 4, sine of 45 degrees is again 1 over square root of 2. So again, the 4 in the denominator, and then you cancel these out. So the value of S1 is equal to pi over 8. And so what that means is that the value of 16 by pi times S1, well, that is just equal to 2. So the answer of question number 1 is 2. Let's go to question number 12, or the second part in this stem. And this is going to be a bit more complicated, so let us try solving this problem. So the integral S2, well, that is going to be equal to from pi over 8 through to 3 pi over 8 of g sub 2x, so that is 4x minus pi, multiplied by sine squared x dx. Now, what we can do now is factor out 4 from here, 4 from the modulus, and that will give us 4 times the integral from pi over 8 to 3 pi over 8 of x minus pi over 4, multiplied by sine squared x dx. What else can we do with this? So let us just try to write this in terms of angles that are a bit easier to comprehend. So pi is equal to 180 degrees, and so pi over 8 is 22.5 degrees, and so 3 pi over 8 is going to be equal to 67.5 degrees. What else can we do with this? Well, another observation that we can make is that the sum of these two angles, well, that is just equal to pi over 2. That is 90 degrees. And we know for a fact that we can apply apply the King's rule. I'm not sure whether you're familiar with the terminology, but the King's rule is basically just says that if you have a definite integral that looks something like this, you can still keep the a's and b's in the same order, and instead of the x, you can put in a plus b minus x. So let's try that, because usually definite integrals don't really require that much of thinking over it. We could have applied the King's rule here as well, though. Since we just had sine squared, we could have easily just put in here, and that would have been an easier method. But anyways, we can try it both ways. So the sum of these two limits, pi over 8 and 3 pi over 8, that is just equal to 90 degrees, pi over 2. So we'll just put that in right here. So this is equal to 4 times 3 pi over 8 from pi over 8 of, now the modulus of pi over x minus pi over 4 times sine squared of pi by 2 minus x. I've just put in pi over 2 minus x instead of x everywhere, and this gives us, again, let me just write the integral completely. This gives us the modulus of pi by 4 minus x times sine squared of something. But notice that sine squared of pi by 2 minus something is equal to cos squared of that number. So I can just write that down there. So cos squared x dx. This is also equal to S2. One more tiny observation. We know for a fact that absolute values don't really take into consideration whether the number is positive or negative. It just spits out the same number regardless. So we can just quickly write that x minus pi by 4 mods is equal to the mod of pi by 4 minus x. As simple as that. Now we have these two equations right here. S2 is equal to this, and the other equation is this. Let us now add these two. And this is a really classic trick that you can employ to make your lives easier. So 2s2 is equal to 4 times 3 pi over 8 pi over 8. And since we are summing the integrals, we can also just write inside the integral the sum of both the integrands. So pi over 4 minus x, its modulus multiplied by sine squared x from the first integrand, and and the second one is this. So pi over 4 minus x times cos squared x dx. What next? We can now take these two things, sine squared x and cos squared x. We know really trivially that they both add to 1. So taking that into consideration, you will now write this. Since both of these sum to 1, you are just left now with this modulus, this absolute value. So x minus pi by 4 dx. Now there are many approaches that you can take. This is a quite easier integral than what we started with. What I would like to do is really just go into a graphical approach, because I think it's easier to visualize. Oops, that's quite bold. I guess, no. Perhaps this one? Right. So if this is the x-axis and this is the y-axis, and if this point right here is pi over 4, the graph of this function, x minus pi over 4 mod, looks like this, right? And the limits are pi over 8 and 3 pi over 8. And when you put in 3 pi over 8, the value of this function, well, that comes out to be equal to the mod of pi over 8 minus pi over 4 mod, that is just equal to pi over 8. And if you do the same thing with 3 pi over 8, you also get the same thing. That's just a quick substitution. So there is pi over 8, and the area that this integral right here signifies is actually just equal to this. So this region right here, well, that's just a triangle, and it is equal to 1/2 times base times height. The base right here is equal to pi over 8. The height is again equal to pi over 8. So 1/2 pi over 8 times pi over 8. And notice there are two such triangles, so you double that. And to find, and you put it right inside here, so that gives you 4 times 2 times 1/2 of pi over 8 squared, and 2s2 is equal to this. So you